marks will be given according to the lab report. So in the lab report, we divided into two parts. One is the assessment of understanding. Later on, there are some questions that you have to answer, and then the rest will be the lab report. And then regarding how we mark the lab report, you can go to Spectrum. So where's Spectrum? So this is the lab report marking rubric. So you can come to the Spectrum, log into the Spectrum and download to look into the detail on how we mark the lab report. So basically, for example, if we're talking about title, so if you want to get the full marks, make sure the title, you identified the complete subject and the purpose of you carrying out the study. And then objective, make sure you set a concise and accurate objective so that throughout the experiment or the lab report, you can write towards how you achieve this objective. I will talk about this later. And then for the introduction, basically is about you have to justify why it is important to carry out this experiment and then how it can be carried out. And then for experimental, I have a video and some write-up. Later on, you have to summarize it on how this experiment can be carried out. So basically, this is something more or less like this. So if you want to get a full marks, then you try to follow the instruction from this part. And then for the lab report, it is consisted of, you can put a cover page where you indicate your name and your metric number. Then followed by, title. Then objective, introduction, material and methods. This is about how experiment can be carried out. Result and discussion, conclusion, references. And then if you want to put any additional data, you can put it in. For this lab report, I hope that you can put it in a more tidy way. So if you have a table, so try to label it with a numbering. You can start with table 1 and follows. And then for the figure, you can start with figure 1, and make sure you give the caption. So this format you can see from a lot of books. So where they presented the table or figure, they always number it. So during the discussion, if you want to refer to that particular figure, then you can write it in the result and discussion, saying that according to the figure 1, the result look like, how's the result look like, or whether the concentration increase or decrease and so on. Okay, so basically the lab manual can be obtained from the Spectrum. It's just a short write-up. And then I have prepared a website. I want to make sure you can, because all my data, the raw data is available on this website. I have WhatsApp you the link. Can you try to see whether you can open this website or not? I share in the chat area. Can you try to click to these links, see whether you can access this website or not before we proceed? Can you open? Okay, so I assume that everyone can open. I will assign experiment 1 to you. So this experiment is about preparation of fatty acid butyl ester and the determination of fatty acid profile of oil by GC. I have to make sure you can access this website because all my data and experimental is here, including the video and raw data. This raw data is important when you need to do the calculation and data interpretation here. I will brief you along with my presentation slide. Okay. If I'm too fast, you are not understand, then you can raise your hand or type in the chat box so that I can repeat. So in this experiment, we are going to determine the fatty acid. So I hope that you know what is fatty acid. So fatty acid is consisted of a long alkyl chain. This is hydrocarbon. And a COOH group. This is a carboxylic acid group. So when you see this structure, we call it a fatty acid. So if we talk about cooking oil, so the oils that we are using it to cook every day, it can come from the plant, basically the plant like olive oil, come from olive. And then we have in Malaysia, it's more common palm oil, it come from palm fruit. And then we have sunflower oil, corn oil, and so on. So this oil, this is how the cooking oil look like. The major composition of this cooking oil is actually called triglycerides. So this is triglyceride. This triglyceride, it is consisted of glycerol. This part is glycerol and a fatty acid chain that bind to this glycerol. So this structure we call it triglyceride. When we consume or we eat this food into our stomach, this fatty acid will be hydrolyzed, and then it will turn into a free fatty acid in our body. Fatty acid here can be divided into saturated, unsaturated, or monosaturated fat of fatty acid. So you can look from, if you go to the supermarket, you buy cooking oil, you can look at the ingredient. Most of the time they will label it as saturated fat, monosaturated fat, and polyunsaturated fat. This is very important to our health. For the health reason, we want to reduce the saturated fat because saturated fat, it can accumulate on our blood vessel, so which cause the high blood pressure or hypertension. So the good fat that we need is actually unsaturated fat. So this, this is a saturated fat. Or you want to call it fatty acid also can. So it is a hydrocarbon chain. Unsaturated fat, it is consisted of the fatty acid chain with the double bond. So if you see that this one double bond, we can call it monosaturated. Sorry, monounsaturated. This is monounsaturated fat. If this fatty acid has more than one double bond, for example, this part we have 3 double bond, we can call it polyunsaturated fat. So it is important in most of the cooking oil industry, when they produce the cooking oil, they need to label this. So if the food that containing a lot of unsaturated fat, then it is a good cooking oil, which is good for our health.
这它也没有加啊。这个整了下。哎呀，我的玩具。
Given different types of oil, and then you have to calculate. You can put it in the way where on how to calculate the percentage of saturated versus monosaturated and polysaturated. If you go to the website, you scroll down the raw data here, or even I have listed down in the chemical and samples. So you can see from here, there are coconut oil, olive oil, sesame oil, and corn oil. So we have 4 types of samples. So you can set your objective. For example, you if you want to determine the saturated and unsaturated fat in these 4 cooking oil, then you just write it down, and in the lab report at the end you have to calculate whether this oil contains how many percent of saturated versus unsaturated. I let you to decide your objective. Okay. In terms of sample analysis, triglyceride is too big to be introduced.
那你就先撤点，这儿行不行？
Cannot analyze triglyceride
再低一点，最低啊， 高一点。
too large.
我说这个现在低，对对对。
So usually what we will do in the lab is we do a hydrolysis.
跟它平，是不是？
We can hydrolyze it using acid or a base. So when we heat this oil with acid or base, then this part will be broken, this bond, and at the end it's turned into
这太是不是？
alcohol.
啊？特好，特好，特好，特好。
This is fatty acid.
好了，不行，特好，你先好，我知道底下不
The
行。
hydrolysis, what we will get is the fatty acid, which is too polar to be analyzed in GC.
行了。
So if you inject this into GC, we might not be able to separate this component. If we would like to know the percentage of saturated fat and unsaturated fat, we need to make sure in the GC this compound is separated so that we can do the quantitation.
刚才他提问了呢。
So since this is too polar,
小姑娘咋回我也没
we are not able
网不
to
好。
get the good
他嘚
separation.
瑟他就嘚瑟的，
Then what we
这
will
还干啥？
do is to
就整这事儿。
derivatize
反
it,
正这一问问题的时候总哪装死，
fatty acid without ester.
总显示自己智商不够。
So you can see from the methods later on, we are using sodium hydroxide and then added with methanol. This sodium hydroxide will responsible to break the methanol to form esters. This is the ester group. The purpose is to reduce the polarity so that it can be analyzed by using GC. I believe you have learned what is GC. I will not explain it too much on this. So just to recall a little bit, GC, it is consisted of heated injector. So most of the injector, we can heat it up to like 300 degrees Celsius maximum, so that all the sample will be evaporated into gases, and the gas will push by and the samples will push by the carrier gas into the GC column and perform a separation. So at the end, you will get a chromatogram. So this is how a chromatogram looks like. So I have listed down the tasks now for you. So you need to prepare a lab report. Based on your creativity, set your own objective for this experiment. Write the procedure for the sample preparation. So the procedure can be obtained from the website. You need to go through this video, or you can refer to any literature or papers on how people analyzing this and summarize it step by step on how to prepare the cooking oil until it can be analyzed by a GC. And then by using the raw data, you have to calculate the concentration of each fatty acid methyl ester in the selected cooking oil. After that, you can base on your the objective that you have set to calculate the saturated or unsaturated oil or the component inside each of these oil. And then you can also compare which type of oil is more healthy if we use it as a cooking oil. And you need to answer the question at the end of the lab report. So the question is here. These are all the questions. Number 5. Please, in the lab report, put a separate section to answer all these questions. So far, is it okay?
It's okay, doctor.
If not okay, you have to let me know. I can explain again.
It's
So,
okay.
whatever it is. Okay, so about data interpretation. I show you one example first on GC. So if you go to the raw data, you can click any oil sample. Then it will link you to reports. This is a report generated from the cooking oil analysis of coconut oil. Okay, so we have done the hydrolysis and then prepare the samples and inject into the GC. This is the report that we get. Okay, each of these will representing the fatty acid methyl ester from the cooking oil. And then see from here, this is the abundant, the signal. And then at the x-axis, we have the time, the retention time. So if you scroll down from the report, you can see we have retention time. But of course, you can see a lot of, there's a long list, but but during the analysis, we have shortened the chromatogram so that it's look bigger. So you can see from here, we start from minutes number 6. So that is the reason why you cannot see any peaks below minutes number 8. Okay. So basically, we have to start from here. So the retention time 8.159. Okay, this is the retention time. Forget about types, forget about width. The most important data that we need is the peak area. So this is the peak area generated from this peak. And then 10.666. So the peak area is 37.9. So the rest you can forget about it. But now the problem is how we are going to identify what is this peak. It is representing which fatty acid methyl ester. So how we are going to do it is by referring to a standard. So for this lab, we have purchased the standard. This is FAME mixture ranging from C8 to C24. So those are the compound that containing inside this mixture is listed here. Start from number 2 to number 15. So how to calculate this C8 and C to C24? So for example, we have methyl octadecanoate. So it is inside here. Methyl octadecanoate, which is number 8. Okay, number 8. So we have to count the number of carbon. 1, 2, 3. Count to here. This for the ester part, this one, please do not count the carbon here. So for this, we have C18. So if you refer here, it is in between. So it is C18. So if C8, so we should have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So this is C8. And then, how about this? Oleic acid methyl ester. So it is also here, number 9, oleic acid methyl ester. Oleic acid methyl ester, we have 1, 2, 3, 4. So it is also C18. Okay. So for this one, 1, 2, 3, 4. This is also C18. So to label it so that we can, because all C18, if you label C18, we do not know which is which. So basically, for the fatty acid labeling, those without double bond, we will label it as 0. With one double bond, 18 to 1. With two double bond, 18 to 2. So this is how we label the fatty acid. You have to, if possible, you have to draw the structure so that you know how this look like, how this compound look like. So basically, it is methyl octanoate means is C8. Decanoate is straightforward C10, C12. So why is all even number? Because if the oil is from the plant, basically it is all even number. This is C14. If we buy this standard, this is what we call standard. The supplier will give us the certificate of analysis to show the content of their standard chemicals. So this is the certificate given by the supplier. Okay, now we have to use this to identify. We have to use it to identify the fatty acid methyl ester in our cooking oil sample. So how we are going to do it is we have to dissolve this sample or standard into a suitable solvent and run using our ONGC. This is the chromatogram generated by the manufacturer, but look like they are using a different column. If we have the same column, then we should be able to get the same profile. But in this case, in the lab, we are using another types of column. That is the reason why the patterns is look like the illusion patterns is different from here. So, but based on our knowledge on GC, we still able to assign. If based on the concept of separation based on the boiling point, okay, the compound with the smallest boiling point will be eluted first. Because it is having the lowest boiling point. So based on this concept, we can start to assign C8, which is the smallest one, and C10. The second one, C12, C14. Things will become complicated when the fatty acid methyl ester with the double bond appear. So in this case, you can see here, you have to check the structure to see whether it has the double bond or not. Now the question is, if we compare C18 to 1, C18 to 2, so under this condition, which compound will be eluted first? So it can be or so now we have to identify this. So far, okay? Because all these are very close in boiling point. The boiling point is very near. So we have to identify what is the sequence. It's either follow this, sequence number 1, or sequence number 2. How we are going to know that? Because at the end you can see there are lots of peaks here. So this is very clear. This one is C24, the last one. Okay. So how we can do it is to identify whether which type of GC column that we use. If we would like to compare the polarity, can you guess which one is more polar? The one with double bond or without double bond? Can you guess? Can you try to guess which one is more polar? 1, 2, 3. The most polar one is number 1 or number 3? Never mind, you just guess. You type in the chat box. No idea. So if we would like to compare the polarity, okay, the one with double bond are more polar. So in terms of polarity, the sequence will be from number 3, which is the most polar, to number 2, and to number 1. So this one is the most polar. This one is less polar. So now it's depending on the column that we use. If we are using non-polar column, then we are going to get this sequence. Because polar, the non-polar compound will retain longer in the GC column. If we are using polar column, then we are going to get this sequence. Okay, now we have to go back to see our methods. What is the So the column that we use is ZVFAME. This column is specific for fatty acid methyl ester. So it's labeled FAME. So the information is here, but we do not know whether it's polar or non-polar. So if you buy a column, you always need to refer to the supplier to get the column information. So the information can get from this link. So if I click on it, so these are the information about the column. I make it larger. And then this is their analysis of results. But of course, they are using the standard with more FAME. Our FAME is only containing like 14 compounds. But for them, they are using the one that ranging from C4 to C22. So which is consisted of 37, but this is not important. The most important thing is we want to see the sequence. Okay, look at all the C18. So you can see the C18. We have the peak from 16, 17, 18, 19, 20, 21, and 22. So 16, 17, 18, 19, 20, 21, 22. These are the peaks of C18. Okay. Based on this sequence, we know that the C18 to 0 will be eluted first. C18 to 1 eluted later. And C18 to 2 is after C18 to 1. So meaning that the most polar one will eluted later. So in this case, it is following this sequence. So your job now is to tag this chromatogram, label it. Label all these FAME into this chromatogram. Based on the concept that I'm talking. And then, if possible, you have to prepare a table. Prepare a table. To make your job more tidy. You have to prepare a table. Where it is consisted of sorry, my table is not very straight. The FAME, you can put the name and label it, for example, C8, and name C10, and so on, and then write down the retention time. For example, C8 is 8.162, so you put 8.162, and C10 is 10.670. So do it for the rest. And then another information information that important is the peak area. So for example, C8 is 8.162. This is 8.162. The peak area is 29.81. And then the 10.670, which is C10, the peak area is 32.32. Prepare this table for the standard, because later on in the samples we have to identify the FAME according to the retention time. So the first task you have to do is assign this. You can get this information from the website as well. So from the raw data, you can click here standard solution of FAME 1000 ppm. So if you click, you will get the reports for the analysis of standard. Okay, so I just use one of the example here. This is from the coconut oil. So now we have to you have identified, I assume that you have identified the retention time. Look for the nearest retention time. So for example, C8, in this sample we have 8.159. So the nearest would be 8.162. So we can label it as C8 based on the retention time. And then for the second one, we have 10.666 here. The nearest is 10.67. You will run a little bit, but it's quite near. So you can put it as C10. Then the next one is this one nothing. Okay, you ignore it. 13.002. The nearest one is 12.94, which is C12, and so on. So this is how we identified the peaks according to the retention time. So regarding the calculation, this is the standard that prepared using 1000 milligram per liter. So we inject 1 microliter into the GC. Then it's generate, we can calculate like 1000 milligram times 1 microliter, you are going to get like 1 times 10 to the power negative 3 milligram. Okay. This is the amount of the standard that we inject into the GC. So you can assume that each of the SAME is having the same concentration. So in the standard solution, this peak is having 1000 milligram per liter. This peak also 1000 milligram per liter. This peak also. So all these having the same concentration. So with this, we know that once we inject inject into the GC, it is consisted of 1 times 10 to the power negative 3 milligram of C8, C10, C12. So if for C8 as example, this weight will generate the peak area of 29.8. And then in the samples, what is the peak area of this? So you can go back to the website, look for the information for coconut oil, get the peak area for 8.159. So we look at 8.159, the peak area is 1033.42. So I put it as 1033. So we do not know 1033 what is the concentration, right? Or what is the amount. So what you can do here is use the ratio. So at the end, you can calculate what is the amount of C8 in this sample that injected into the GC. So I hope that my explanation is okay for you. You have any question? You can ask me question because if you just keep quiet, I'm not sure.可以吗？你们有什么问题吗？
No questions, Doctor.
So, can you try to interpret assign this peak first, okay? You do the assignment. You jot down, the first task is to assign this, okay? And then prepare this table. Then assign the fatty acid methyl ester on each of the sample, okay? On each of the sample. And then calculate the amount of the FAME in these samples. So we have how many samples here? We have coconut oil, corn oil, olive oil, sesame oil. So 1, 2, 3, 4. So each of these you prepare a table again. Prepare a table, for example, table for coconut oil. So same thing. FAME, retention time, peak area, and the amount of each FAME. in milligram or microgram? Can you do it for the 4 types of oil? And then I will, and then you can show me the this data when it is ready, and then we can discuss it. You pass to me to have a look, okay? And then we have 1 week time, so I just hope that you can pass it to me by before next Friday, and then next Friday we can have another Google Meet session to discuss how we are going to present the data. Is it okay?
Okay, doctor.
So if okay, then you can do the work, and then if you have any questions, please WhatsApp me, so I can answer your question straight away so that you can move forward. And then I'm waiting for your calculation. So when the calculation is okay, then I will let you to proceed with writing a lab report. And then before the final submission of the lab report, I will take a look, so to make sure your lab report is okay before you submit. So is it okay?
Okay, doctor.
So I will meet you again next Friday, 10 o'clock. Same link to check your data, whether your calculation is correct or not. So if needed, both of you can do a discussion. And if need my help, just text me. Okay?
Okay, doctor.
Okay, thank you. So I'll see you again next week. Or if you need any Google Meet session or anything unclear, you just text me. I can on anytime, because I will be here for 1 whole day, because this is your lab session. Okay, so see you again. Just let me know if you're facing any problems. Thank you very much.
Thank you, doctor.